Dear students, good morning, namaste. We are in the chapter vectors. We completed 6 parts. In the 6 parts, definition of vector, types of vectors, and one exercise is also completed, that is 10.1. Now we are in the component of vectors. In the 6th part, I taught about the component of vector. Once again, I want to repeat this theory. Okay, now? Yeah. The component of a vector. The component of a vector means for any vector, graphically we can show from A to B, a direction is there, some length 10 units or 15 units is there. We can understand graphically, geometrically we can understand. But mathematically, algebraically, this is the vector. Just like we have to give one notation as well as one equation. With the numbers we have to show that this is a vector without drawing a diagram of a vector, not geometrically. For that purpose, we have some concept, that is component of a vector. Components. It is a components of a vector. You see that already I taught you, we discussed. As we know, OP bar, that is, it is a 3-dimensional geometry, horizon, x-axis, y-axis, z-axis. Already number of times I told you that it is a room. In the room we are. Now I am in my room. You are in your room. It is that corner you assume horizon, it is x-axis, and that is y-axis, and it is a z-axis. Okay, now? P is a point. O is horizon, P is any point. Let P be a point. OP bar. Okay, now? OP bar. That OP bar is already I will give all the information about this diagram and how can we get xi cap plus yj cap plus zk cap. This is already over. Okay, leave it on. So OP bar, where P is a point, you see, OP bar is with xi cap plus yj cap plus zk cap, ij, k. I cap, j cap, k cap are the unit vectors along x, y and z axis. Here it is I cap, it is j cap, and it is k cap. Where x, y, z are the, actually those are the coordinates of the point P. Where you see the position vector is a position vector of point P. This OP bar is nothing but a position vector of a point P. Where P is a point, it is in the 3-dimensional x, y, z, x coordinate, y coordinate, z coordinate. Where these components x, y, z are the scalar components. Here is the important. The scalar components, clearly. Scalar components of the vector is x, y, z. And vector components, a difference is there. Vector components means xi cap, yj cap, zk cap. Simply x, y, z are the scalars. If I add the unit vectors I cap, j cap, k cap, then they will become as a vector components. And again, here is important. Up to that one I got you. Here the scalar components which are x, y, z are called the direction ratios. It is this concept, direction ratios. This concept is in the geometry it will come. In the 3-dimensional geometry. After completion of vectors, we can study that one. But before that one, we have to take that concept. It is interlinked. Vectors. After vectors, we deal 3D geometry. But some concepts we have to take it on. Okay, Rana? Yes. Direction is, it is a name simply. What are the directions? Clearly we will discuss about that one in that chapter after completion of this vector chapter. But here we have to take that one. The scalar components which are x, y, z are also called as DRs, direction ratios. D means direction, R means ratios, direction ratios. Okay now? It is up to that one. Any vector components are there. In the components there are two types, scalar components and vector components. And also those components are called as direction ratios. And one more thing. You see in that diagram, O is origin 0, 0, 0 and P is any point in the space. Then what is the distance between O and P? Between O and P, the distance is same. x2 minus x1 whole square plus y, y2 minus y1 whole square. It is known in a two-dimensional geometry, you know it. But in three-dimensional geometry, one axis is extra. That is x2 minus z2 minus z1 whole square. x2 minus x1 whole square. There x2 is x, y2 is y, z2 is z. x1, y1, z1 is 0, 0, 0. We know it. So x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square with root. Okay now? That is x square plus y square plus z square. So the length of OP, the distance between O and P. In other words, in a vector chapter, it is called as the length of the vector, the magnitude of the vector or the modulus of the vector. Okay now? OP is nothing but the modulus of OP bar. That is what root of x square plus y square plus z square. Clearly in words in the statement we have to tell. If any vector is there, we can find its length. That is the modulus of a vector. Or length of vector also we can say it is a length. Length of a vector or magnitude also. Magnitude. It is the magnitude of a vector. Is, observe it, is the positive square root. It is important. The positive square root of sum of components or otherwise DRs of given vectors. What is the x, y, z? DRs or otherwise components. Simply say components. Specifically scalar components. So x, y, z, DRs are components. X square plus y square plus z square means the sum of, their sum is there. Sum of squares of, okay na? Sum of square root, the positive square root of sum of squares of, and squares are there. It is squares. Squares of, sum of squares of components. You see, it is a positive square root, yes, okay. For which expression positive square root is there? For x square plus y square plus z square. Sum is there. So sum of squares of components. X, y, z are components or otherwise DRs. Okay now? For the given vector. Okay now? Here also a positive square root. Square root means root 4 means plus or minus 2. But it is a length, so we should not take a negative. It is always positive square root of sum of squares of components or otherwise DRs of a given vector. So for a vector, we can find scalar components, vector components or otherwise DRs also and length also. You see one example. If you take one example, if OP bar is equal to, simply we take R bar or otherwise A bar or L bar like that, single letter. OP bar or otherwise A bar. It's a given vector. 3i cap plus 4j cap plus 5k cap. For this vector, what are the scalar components? Scalar components are 3 gamma 4 gamma 5. Okay na? 3 gamma 4 gamma 5. And what are the vector components? 3i plus 4j gamma 5k. Okay na? And what is the magnitude of vector A bar? Magnitude or length of a vector or modulus of a vector all are same. What is the modulus of this vector? The notation is also like this with the modulus of A bar. is 3i plus 4j plus 5k with modulus. And by definition it is 3 square plus 4 square plus 5 square. That is 9 plus 16 plus 25. That is 50. Root 50 is 5 root 2. So its length is 5 root 2. Okay, Dada? So for a vector a bar, that is 3i cap plus 4j cap plus 5k cap. First, drs. What are drs? 3 comma 4 comma 5. Look at that? Yeah. And modulus of a bar is 3. In 5 root already we solved 5 root 2. And what is the point? P is equal to simply 3 comma 4 comma 5. Okay, now in some books, test books, we are given the vector. It is given like that. Vector 3 comma 4 comma 5. We may feel that it is a point. Of course, it is also a vector. It's a notation. 3 comma 4 comma 5 means they are components. What is a vector? 3i cap plus 4j cap plus 5k cap. Like that also, shortly it will be given. It will be given. Okay, Nana? That is the theory of this components of a vector. Is it clear? Okay, na? Yeah. Okay, component vectors. Already we discussed that is scalar components, vector components and its length. Okay, na? And drs also. Drs is nothing but the dr of a vector means the drs of vector, direction ratios of vector means it is simply scalar components. We may call it simply components or drs. Okay, na? Don't confuse. Vector components will not asked and it will not be used in anywhere. While we are solving the problems in the exercise, only components, that means scalar components, or otherwise drs, they are called as drs. Then only often it will come. Okay. Now, very important concept. You see the diagram, observe that diagram. This is, as already we know, that is x-axis, y-axis, z-axis and r is an, o is a point. I mean, p is a point. Okay. Here we join OP. OP direction is there, OP. And OD also. Already AD is there, AP is also there. Here you have to try to understand. It is a three-dimensional geometry, but if you draw the diagram means on the board, it will reduce it as a two-dimensional geometry. Try to understand that. I suppose OP line is making an angle alpha. This is alpha. This is alpha. Alpha is the angle made by the line OP with the x-axis. Okay, now? And AP is joined. For some time you forgot this one. You forgot. You delete this one. It is not there. Everything is not there. Just you observe. P is a point and OP joined, AP also joined. Now I will tell that the triangle OAP, don't confuse, D is not there. You simply leave it out. D is not there. Only OAP is right angle triangle. At A the angle is 90 degrees. I will tell. Will you agree? In the two-dimensional geometry, it will become as a triangle, equilateral triangle, or having some 60 degrees or 70 degrees like that. It is not 90 degrees. You may feel that. But you assume, you imagine that it is horizon, just observe it. It is horizon, it is x-axis. Okay, na? X-axis, horizon, y-axis, z-axis. Here is a point. Try to understand. Na? Here is the point OP. That OP, yeah, OP. This OP line makes an angle alpha with x-axis and beta with y-axis and gamma with z-axis. Okay, na? Please try to understand. Horizon, it is x-axis, z-axis and y-axis. From O to, here is a point P. O to P. P is a point. OP bar is a given vector. P is a point. Yes, okay. This vector makes an angle alpha with x-axis and beta with the y-axis and gamma with the z-axis. Okay, now? Try to understand. Then alpha, beta, gamma are the angles made by the vector OP with x, y, z axis. Any vector means no doubt it makes angles with x, y, z. Okay, na? No doubt at all. Suppose OP line is totally lies on x axis. This is OP line. If this OP line lies on x axis means it makes 0 angle with the x axis and 90 degrees with the y axis and 90 degrees with the z axis. Suppose OP line, this OP line, it totally lies on x axis. That is alpha is 0, this is beta line, this is gamma. But here it is not possible to understand. This is alpha. If OP line lies on x axis means alpha is 0, but it is 90 degrees, it is 90 degrees. Suppose OP line lies on y axis, then with beta is 0, but alpha is 90, gamma is 90. Okay, that is a different one, leave it out. Any vector means OP bar, no doubt it makes some angle with x-axis, y-axis and z-axis. Okay, now whatever it may be the position. Suppose not only OP, OQ is there. It is also making some angles with the x, y, z. Okay, now for example, OP line making angles alpha, beta, gamma with the x, y, z axis. Then cos alpha, cos beta, cos gamma are called direction cosines. Okay, Nana? Direction cosines means direction cosines, causes. Direction cosines means they are cos alpha, cos beta, cos gamma, where alpha, beta, gamma are the angles made by the given OP line or OQ line or OR line or OP vector or anything. Any vector, no doubt. If you take any vector, no doubt it makes some angles with the x, y, z. For those angles, if you connect cos alpha, cos beta, cos gamma, cos 30, cos 45, cos 60 like this, we can get those concepts are called as direction cosines. Okay, Nana? So, once again, we will come to the point. Again, I draw the diagram. There it is some clumsy. It is horizon, it is x-axis, y-axis, okay. It is a point P. First point P is there. Point P is there. We don't know, we should not join. P is a point. From the point like that, we can construct a diagram. That is, you know it well. It is a parallelepiped, or otherwise it is called as a cuboid. Okay, Nana? Here is x coordinate, so it is x, it is y, and it is z. We join OP. That OP makes an angle alpha. And again we join AP. You see now, it is already the x-axis. P is a point. From P to A, it is perpendicular. It is left to you only. You have to understand. OP vector is there. Here is a line y-axis. And OP vector is there. That vector makes angle alpha. And from P point, if you draw a perpendicular on x-axis, okay, na? Not perpendicular, you see that angle. Okay, na? This P point to A, it is P point to A, it is certainly, it is perpendicular. Okay, na? So here is, it makes 90 degrees. It is not possible to say You try to understand. Here OP is there from corner, horizon. OP is there. But it is lying on the plane, not line. It is like this. And AP is like this. Here is 90 degrees. Here it is 90 degrees. You slowly try to understand. Okay, now? You are sitting in a room by seeing this video. You assume. This is x-axis, z-axis. This is xz plane. Okay, now? That wall is a yz plane. The floor is a xy plane. Okay, now? Suppose here is in your room. Backside of you assume that is a room. That corner is point P. Try to understand. Okay, now? That point is P point. That is horizon. P point. Okay, now? That is E point, that corner. Like that you assume. This is A point. And here is, that point is B point. Okay, now? That point is below the P point is D point. And that point is F point. Okay, now? This is C and that is F. You imagine. It is not possible to explain. You also try to imagine that one. Then point P is there. Point P to A. This is A. That wall, this is x-axis. This is 90 degrees. Is it not it? A point, P point is there. OP. Okay, na? OP. Just like you assume. This is OP. Vector. From P, A. X-axis. A. 90 degrees. Okay, na? You try to understand it. Yeah. So, in the triangle here, in the triangle YP is a right angle triangle, we know it. What about cos alpha? Cos alpha for 90 degrees, adjacent side is OA. Adjacent side by hypotenuse for 90 opposite side OP. Okay, na? That is OA is x, we know it, x coordinate. OP is the distance or length of vector. It is root of x square plus y square plus z square. We know it well. So cos alpha. It is denoted by small l. Okay, na? It is a notation. So the very first DCs from the set of DCs, the first one is cos alpha, where alpha is the angle made by the vector with x-axis and its notation is the small l. Small l means cos alpha, that is equal to about x-axis, about x coordinate, x by root of x square plus y square plus z square. Okay, now? Similarly, m is equal to cos beta. Beta is the angle made by the vector with y-axis. But here it is very clumsy. Just you assume. It is related with y-axis, y coordinates. And y by x square plus y square plus z square only. That is a common OP. Length is OP. And n is equal to cos gamma. It is z by root of x square plus y square plus z square. Okay, hence the drs, it is called as a DCs. DCs means just pass. Observe it. The last concept, the DCs. What are the DCs? DCs means direction cosines. Direction cosines. Already we know that. Don't confuse with DRs. DCs are different one. DRs means for any vector, DRs means the components, the coefficients of ijk are the multiples of ijk. That is x, y, z. Coefficients, multiples. Those set of three numbers are called first, they are components. Next they are called as direction ratios. Already we know it. But here it is a direction cosines. Direction cosines are a different one. Direction cosines means, I will write it, that this is of vector or p bar are, those are x by, first of all it is cos alpha, cos beta, cos gamma, where alpha, beta, gamma are the angles made by vector OP bar with axis, plural form, with axis. Simply I am writing with axis means x axis, y axis, z axis. Okay, leave it out. Okay, now that is the alpha, beta, gamma are the angles made by the vector OP bar. Made by the vector OP bar. OP bar is a vector, we know it. That makes some angles alpha, beta, gamma with the x, y, z axis. Okay, now then cos alpha, cos beta, cos gamma are the direction cosines. What are the direction cosines? Means they are cos alpha, cos beta, cos gamma. Where alpha, beta, gamma are the angles made by the given vector with the x, y, z axis. Okay, now very clearly, shortly, we may say it is shortly. It's continuation. I will give the continuation. L comma M comma N are the disease of vector OP bar. Okay, now where L, M, N means there are xy root x square plus y square plus z square. Y by root the same and z by the same root. Why? Because what is L? L means cos alpha. Cos alpha means x by root x square plus y square plus z square. M means cos beta. Cos beta means already we discussed. Y by root. Root is there is. And z means N. N means cos gamma. Z by root of the same thing will repeat. Okay, now you see once again I want to tell clearly. Suppose one example. Suppose OP bar is equal to 3i plus 4j plus 5k is there. Then we know that DRs are direction ratios 3 comma 4 comma 5 or simply we may call as components. But this is or it is 3 by root of 3 square plus 4 square plus 5 square, 4 by the same root, 5 by the same root. I am not writing here. You assume that. That is 3 by, it is 5 root 2. 4 by, it is 5 root 2. 5 by 5 root 2. Okay, like this. These are the diseases. Don't confuse. DRs are different from DCs. DCs are direction cosines. Alpha, beta, gamma. Cos alpha, cos beta, cos gamma. Where alpha, beta, gamma are the angles made by the vector. Slowly, 1 or 2 times you repeat this video. Okay, Nana? Yeah, okay.